Let's talk about designing systems that stay up. And I want to do so, I want to take examples from the real world and apply them to the designs we're doing now. Super serious, super technical topic. Let's start with a joke. So I was recently flying during the holidays and saw a handwritten sign where someone had put down, "Why is COVID better than Southwest Airlines?" And the answer, of course, is because COVID is airborne. So it's kind of funny because it's true. So, they in Southwest in December had almost 60% of their flights grounded. And there were a number of reasons for that, right? And if you talk to Southwest, they'd say, well, no one could have predicted the surge in demand at the same time as, a lot of weather systems, at the same time as people getting sick. And, to me, that just means it's December, right? That is what happens in December. And so, that's an excuse, right? It's not how you build a reliable system. So, it's going to happen next December and the December after that. So next thing, if you're some DevOps person, you'd say, is what they needed? They needed a lot more planes and a lot more crew. But planes are super expensive, and so are people. But planes completely dominate that. You can't have spare capacity sitting everywhere, and you don't want to provision to peak just for December compared to what you're going to do the rest of the year when capacity is light. So that's not an answer. Then some other people would say, hey, they had these old systems which failed over a system called SkySolver, and so they had to do a lot of manual things. And there's some truth to that one. That SkySolver did fall over because it got a bunch of demand and they couldn't figure out where their crews were and so on. And, in fact, they're going to be investing, I think, close to $1 billion in IT now to sort of address those things, figure out across their mobile systems, where their crews are, all of that kind of stuff. Totally makes sense. But, also not a real thing that I feel like we can learn from. Not all, we don't all have these ancient systems out there, but we should be adapting from a reliability perspective. And that's a lot about testing to depths that we don't expect people to run into from a load perspective. For me, the key question is, why did this happen to Southwest to agree it did not happen to United and American and Delta and all these other airlines? And there's actually an interesting answer to that, which is based on the technical architecture of how they do their routes. So Southwest tends to do point-to-point locations. So the plane goes from here to here, then goes from here to here, and then there to the other place. And therefore, if any of these routes, points, individual trips get disrupted due to crew or weather or plane not being available or whatever, it actually disrupts the rest of the chain. Whereas most other airlines do a hub and spoke model where, you fly from, let's say, San Francisco to Denver and then from Denver to Atlanta. And so it's much more resilient in the case of failures because rather than needing each unique route to be duplexed or, have coverage, you can just have an extra few locations at the hub because that'll continue. It's kind of called like an N plus K model where you have like N things that need to work and you can tolerate K failures. So you have to have N plus K units. You can't have K units spread across all of the places you fly to. You can have them in the hubs. You can't have K extra crew sitting everywhere. You can have them in the hub. And more importantly, it's a question of what is the number of failures you're dealing with? Well, it's the entire route. If you're thinking about a graph where every route is kind of independent, if you're going through a hub, you only lose one flight, not, like a bunch more. There isn't a cascade. And so for me, that's how you kind of map what is a failure in something to like how to think about it from a reliability engineering perspective. Now, it's actually more complex than that, right? Like everything. I mean, obviously, the point-to-point thing is something I, for one, prefer because I'd rather not take a connecting flight. It takes me out of the way. It takes longer. It is actually more expensive for the airline as well. But it's just a question of trying to balance cost versus reliability in a economically constrained way. So that's that was my takeaway from that particular outage. Hope you found it interesting. I'd love to see what you took away from the experience and, how you think it applies. And, please put your notes in the comments to this post and I'll answer whatever I can.